everyone. So today in this video I will be talking about what to do when writing out your scratch work for your exams, right? What to do and what not to do. Right? So here's a list. So first things first, you want to put numbers on the left of the margin. You want to skip one line between problems, one column of problems per page, and you can use the back. So I mean cannot have one, two, right? It has to be one column, right? This one's big, right? Large, neatly, and clearly, right? So one, don't put fractions on one line, so don't say like 3/4, right? I shouldn't need a magnifying glass to see your work, right? And what do I mean by neatly and clearly? Right, so I should be able to read your work, right? I shouldn't just be sitting there trying to decipher what you wrote. And what I mean by neatly is it has to be orderly, right? So an example, if you wrote an English paper and you say this is a dog, right? If you wrote it like that, do you expect to get full points? No. You're expected to write this is a dog. All right, in order with punctuation, very clear. All right, same thing with math. It's just like how I write it in class. All right, I use columns. Some people, when they say I don't know, 2x minus 3 equals 0, they like to go this way. Right, that's fine. You can if you want, I guess, but one thing is just don't forget to use your arrows and bring them back over here. Alright, I prefer columns, okay, as you guys know from class. Let me erase this. So another thing, write original equation or inequality. I'll talk about that in a little bit. Box your final answer if applicable. So if your final answer was like a graph, you obviously don't need to box it. Alright, and then some questions it's just a scratch work kind of deal, and you can write your final answer on Alex. Alright, and then 7, write the page number on the upper right hand corner. This is mainly for you, alright, just because I know sometimes especially if you have loose paper, alright, or if you just do something on one page and you just say you did a lot of work and you're like, I just messed everything up, you can just mark it off and continue. Alright, but if you put the 3 or whatever the page number is, it'll be easier to take pictures of. Alright, so let me talk about this doing some examples. Alright, so what do I mean? So put numbers on left of margin, pretty self-centered, or self-explanatory. Put them to the left. So you have this red line, all right, on a line paper, and you just put the number to the left of the red line. All right. And then what do I mean by write original equation or inequality? I don't mean if they say solve for x and give you a problem, you don't have to say solve for x. All right, don't need to do that. If you want to, that's fine, but it's just a waste of time. But what do I mean? So it says solve for x and or solve for y and say that they gave you 1/9 y minus 1/3 is equal to 3. Right? When they say solve for y, blah, 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 all right, you just need to write the equation. All right, same thing. If you were given an inequality, write down the inequality. All right, so if we do this, we can just solve it. All right, again, you could keep this as keep them as fractions and then find the common denominator, yada yada. All right, but you guys already know what is my favorite method. My favorite method is finding the LCD and multiplying it by that. So I'm going to multiply both left and right by 9, right, because that's the LCD here. Okay, again, if you want to do it this way, that is fine. Just make sure you distribute every single term, right? And then I'm going to do, so this is y minus 3 is equal to 27. Right, and then what do I get? I get y is equal to 30. Right, so I know I strained about checking solutions. I do suggest checking solutions, but however, I'm not going to grade all the checking. You have to, so for this one, you have to check the work where you where there's a possibility where there's extraneous solutions. Okay, so that is square roots, rational equations. Yeah. Right. So you could check if you want to. So, and if you don't like the idea of having all of this blank paper on the right, this is where you can check. Right? Technically, you don't have to check this, but this is just me giving an example. Like you can check your work here. So then you have like 1/9 over 30 minus 1/3. Does this equal to 3? Right? So this is going to be 10 over 9. Okay, because this is 3 times 10. Okay, don't do this. This is me just showing. All right, so let me erase this. I'm going to put this in a different color, but just so you guys can clearly see what I'm doing. Okay, this is 3 times 10. So if I do that, this becomes 3. Okay, so this becomes 10. Oh, this is 10/3, not 10/9. Jeez. Okay, minus 1/3. Does this equal 3? Okay, we get 9/3. Does this equal 3? And we get not 3 is equal to 3. Alright, so that means y equals 30 is a solution. Alright, don't forget on ALEKS, most of the solution sets, you have to know this. Alright, this is what I mainly do in class. Alright, so you should be pretty familiar with that. One thing I want to caution, there is one where they have this button, and they also have this with like a box. Alright, this means the empty set. This means you just need squigglies and a box. You can also type it on your keyboard if you'd like. Alright, if you want to make things go faster. Alright, I'm going to erase this. Okay, so say we just did number 1. Alright, and then notice I was given a fraction and I used one line for each number. Alright, I did not put 1/9 y minus 1/3. Right, this is too small. Okay, so this is a no. Alright, so now what I'm going to do, so this was my last line, so I'm going to put my 2 here. Alright, and let's say the second problem was divide. Okay, and so I have like 6 plus 6i over 9 plus 6i. Alright. So again, all I did was write the expression. Alright, so I guess write original equation, inequality, or expression. Alright, and then don't forget here, what we're going to do is in order to get rid of this I, okay, we don't want that to be an imaginary number, or we don't want any imaginary numbers in our denominator, so I'm going to multiply this by the conjugate, which is 9 minus 6i. Okay, remember, so this is an expression. In order to keep this fraction the same, I have to multiply this by the top and bottom. Right, so this is equal. Okay, and so you'll get like 54 plus 54i minus 36i minus 36i squared. All over, and remember this is a difference. This is a difference of squares, but it's imaginary. Alright, so this is going to be 81 plus 36. Okay, so this is going to be 54, and then 36, this is negative 1, so negative 36 times negative 1 is positive 36. Okay, 54 minus 36, that is what, 18? Yeah. All over 81 plus 36 is 117. Alright, so then we get 90 plus 18i over 117, Alright, but our instructions would say make sure it's in the a plus bi, so this is going to be 90 over 117 plus 18 over 117i. Alright, so I know this is not asked in the question, but just to talk about the real part, right, this is 90 over 117. It is the part that does not have the I. Right, the imaginary is 18 over 117. Right? No, it does not include the I. Alright, imaginary part, we're talking about what is the coefficient. Alright, so that's just a little fun fact. I'm going to delete this. Alright, so notice this is a fraction, and notice I kept everything on its own line. Right? And again, okay, you can box this up. Okay, so now we're going to do number 3 and say we were given negative 35, multiply these, negative 35 and then negative 14. Right? So again, when there's negative, we have to take care of the negative first. So this is I times 35 times I times 14. All right. I think this is also a good opportunity to re-talk about this. All right. Because I don't think I really talked about it that well. Okay. So first off, I'm going to do 35 times 14. All right. But before I do that, without even multiplying these together, we want to write the prime factors. All right, so 35 is written as 5 times 7, and 14 is written as 2 times 7. Right. This is also a good opportunity. So say that you get to number 3 and you ran out of space. You're like, oh no. Okay, what you're going to do is you turn your page around or start a whole new page. It's up to you. All right, and what you're going to do is you're going to put 3 continued. Alright, so I know that you're continuing, and you should also put an arrow right here. Okay, so we have, I'm going to rewrite this, so this is negative 1, and then what did we get? We got 2 times 5 times 7 squared, 2 times 5 times 7 squared. Alright, so when you look at this, alright, so how do we know what to simplify? What we should do is we look at every factor. So the factors are 2, 5, and 7. All right, we look at the power. If the power is equal to or greater than the index, it must be simplified. All right, so 2 to the first, that is less than, so our index is 2, right? So if the power is 1 or 0, okay, but we'll just look at the power 1 because if it's something to the 0, it's just times 1. Alright, for the index, so if it's 1, we don't have to touch it. So negative 2, we don't have to do anything, for 2, we don't have to do anything. 5, we don't have to do anything. But what about this 7 squared? 7 squared, 2 is equal to 2. So what does that mean? This means that it's going to be simplified. Oops. Alright, so what do I mean by that? So we could separate this, and this could be 7 squared. Okay. This is 10. And then 7 squared, the square root of 7 squared is just 7. So then we would get negative 7 square root of 10. Alright, you can also do that greatest, look at all the perfect squares, the greatest perfect squares, and try to divide them and see what you get evenly. If you had done that, you would notice that 49 goes into it nicely. Alright, but this is just a way without using your calculator. Right? You don't have to go to this step. If you wanted to, you could have gone straight to this step. Right? It doesn't matter. Right? But that is just how you solve that. Alright? So I think that's what I want to talk about for what you want to do. Oh, sorry. One thing I forgot. Okay. Remember, this is 1, and this would be considered 2. Right? So this is what you want to do. Skip your lines. All right, make sure you don't write fractions on one line. Okay, just write the original equation, inequality, or expression, box your final answer, right, and then put the numbers in. And don't forget to put the numbers on the left. And if you have to continue, just put this little arrow and then just put the number you're working on, like 3 continued. Alright, so this is what to do. Okay, so what do you not do? You just pretty much do what the opposite of what I told you. So if you put like 1, right, so if, and then you would put like 1/9 y minus 1/3 is equal to 3, right? And then some people, they might just say like, I don't know, y minus 3 equals 27, and then they're going to go over here, say y equals 30. Okay, this is not good. You have to show me where you are going. Okay, and then say if they checked here, okay, and then they just put 1/9 y, or 30 minus 1/3, 3. All right, see, that's just small. All right, they keep going. All right, you got to tell me where you're going, so this is not good. All right, again, it's even it has this over here, and then sometimes they might do it over here. That's not good. All right, you need to skip a line. Okay, and if you put like 6 plus, oh, especially don't even do it with this one. This is just, all right, this is big no-no. Okay, again, and then also show your work, because if you had just told me whatever the answer was, like 81 plus 36 over 30, oops, no, this would have been 54 plus 54i, let's see, what, 54i plus 36i plus 36, right? This is also, nope, you need to show me what you're doing, all right, and make sure it's all under, all right? If you had not done that, if it had just been this, I would have just assumed that the plus 36i and plus 36 were not a part of the problem, right? And so don't do that. Don't say this and then 4. Whoops. 4, all right? Just don't go crazy. So if you had done this and then you decided to put your work over here and then your work over here, oh my gosh, no. Right? So I think that's enough for the do's and don'ts. One thing I do want to talk about, like, for this, like, so my examples, they weren't really that long, but say you did something and you used up quite a bit of lines and you have all this half page left. What you can do is you can put an arrow and you can say, let's start back up here. Right? If you want to make your problems into 2 columns, that's perfectly fine. So the secret word that I want you to submit on Blackboard is the word purple. So let's talk about a couple other things real fast. So just a heads up, number 1, 5, 17, 20, you do not need to show work. No work needed. Alright? If you're able to do it in your head, that's perfectly fine. If you want to show it, that is also perfectly fine. Alright? But it is not required. Well, only thing I ask of you, so if you do, so for number 1, alright, just leave it blank. You can, it's not technically a concept question, but you can just put CQ, alright? And then you'll say you do 2, 3, 4, right? Number 5, you will also put concept questions. So please do not skip numbers, right? Make sure they're all there. Same thing, so if you go down and say like 16 and then 17, right? 21, so number 21, you just need to sketch a graph, right? That's all I want to see for your work. So just, yeah, make your sketch. Right, and then you can put your final. You can also put your final answer on the paper. It's up to you, but ultimately, I want the final graph on Alex. Right, maybe put it on paper just in case Alex counts you wrong, or like you accidentally click some wrong buttons. If you have the correct work on here, then I will give you credit. Right, and then lastly, number 23 and 24 are extra credit. I think that is it for today. All right, thank you for listening and good luck on your test.